Good evening. Welcome to CERN. Pleasure to welcome you in this nice science gateway. I am Frédérick Bordry. I am the chair of the CERN Cultural Board, and I was director for Accelerator and Technology. I worked 36 years at CERN, and this is my home. It's a great pleasure for me to open this second CERN Art Science Summit, and now an annual event that brings together leading voice in science and culture. The goal of this summit is to explore the intersection between these two fields and to reinforce the dialogue that they foster when they are together. Since 2012, the Art at CERN has been developing unique programs focusing on bringing artists at the laboratory. Our art program has become a pioneering initiative in art and science that has gained significant recognition worldwide. With this in mind, we see our responsibility to open a public forum to reflect on these important topics. Science shapes more and more our world, help to understand nature, and give us tools to explore it. Many times in history, ideas that seem impractical led to major discovery that changed society and culture. I like to say, at CERN, we make impossible possible. Paul Klee, I like Paul Klee, wrote in his book, The Theory of Modern Art, art does not reproduce the visible, it makes it visible. In another way, the Nobel physicist Jean Perrin, speaking of science, said that science was able to explain the complex visible by some invisible. We can say that science makes it possible to make visible the reality of elementary particles, constituent of matter, in the small world, infinitely small, but also in the galaxies, in this infinitely large. You can transform the invisible by visible equation of some models. In other way, art offers new ways to see science, making knowledge, exploration, and research more engaging and meaningful. Together, art and science reveal the hidden, embrace the uncertainty, and redefine what seems unclear. That help us to explore mystery that has to be still to be discovered. This year's conference is especially significant as it aligns with a key milestone in physics and the impact of quantum science. In this context, to mark the 100 years since the early development of quantum mechanics, UNESCO has declared 2025 the International Year of Quantum Science and Technology. In response to that, our Art at CERN team has chosen uncertainty as the theme of this edition. In my view, it is a concept that encapsulates everything, a fundamental principle in physics, you will hear very soon, a lens through which quantum mechanics reshape our understanding of nature, and a reflection of broader social uncertainty we face today. At a time, I think, of profound change, we come together not only to explore these ideas, but also to imagine new future, and this the language through which we can articulate them. For all these reasons, in my honor, in my privilege, to welcome you to this event and to our community, physics community, and I want to wish you a nice evening and with a fruitful discussion. Thank you very much.
Thank you, Frédérick. Welcome, everyone. I'm Mónica Bello, and I've been, for the last 10 years, running this program. Whether you are joining us for the first time or returning after last year's edition, which was the moment in which you convinced us that this was something everyone liked and like to come back from many places of the world. I know that many of you took a plane or a train or a tram to come here. So all of you, thank you for being here and understanding that there is a conversation to take that is possible. It brings possibilities and is an invitation to think and to imagine. Colleagues of CERN, scientists, artists, partners, and all those passionate about the intersection between art and science, your presence enriches and really gives sense to what we do. So it's an honor to have you here today again. A special thanks to our partners and collaborators, sponsors, including the Republic and Canton of Genève, the City of Genève, whose strategic backing has been instrumental since last year when we started this adventure together. I would also like to express my gratitude to Loterie Romande for supporting this edition and the Science Society Foundation for its continued trust and generosity. The second edition of the summit is dedicated to the theme uncertainty, and as Frédérick said just now, it's an invitation of possibilities. Our aim is to open up this world and to say, what can we do today with the tools we have and the shared spaces that we are inaugurating day by day. They are, I like to think that we are crossing thresholds, and there some passages and caverns and tunnels appear, and we walk through them together in art and science. Today's discussions will reflect this ongoing debate of why disciplines are going hand by hand. And I like to encourage everyone to think of this meeting like from a polyhedral vision with multitude of lenses that blend disciplines, but also experiences and insights. Our guests today are from theoretical physicists, literature and poetry. There are curators as well, filmmakers, philosophers, and experimental musicians. Together we'll try to give faith and respect to this theme, uncertainty, that was inaugurated somehow in science 100 years ago. So let me be brief about the format, but it's something that we have built with a lot of care, and I hope you see it, because we invite our speakers to create conversations. We have conversations, readings, and listenings. On the stage, we will have two conversations between two experts from sometimes complementary fields and experiences. And each speaker will make a brief presentation followed by a conversation between them. Then we will have two interludes between these two conversations, where two very special creators will use words, signs, sounds, and symbols to reflect on time and spaces that we share, and these spaces bring us into this inspirational space that is physics. A final performance, which is I'm super honored to have Maria Arnal here today, because she is an exceptional musician, and I think she is seeking for something, and I hope we can give her this stage to experiment and also to give you a chance to enjoy what she does. She's an amazing singer, composer, and experimentalist. So thank you to Maria for being here. I'd like to remind you that there is a film program. You saw some of the clips of the films, and you can watch them tomorrow, the whole day, in the auditorium upstairs. And then What else? There is translation, French translation, if any of you would like to use it. And about the film program, something very special is going to happen. Among several films that we commissioned or supported over the years, we are presenting the last commission, which is Home, video work by Tanya Candiani. This is the latest art commission of Arts at CERN, and is made possible through the generous support of the Didier and Martin Primat Foundation, and we are really thrilled to have Tanya here speaking about it tomorrow. So that said, without further ado, it's my pleasure to invite our first two speakers to the stage. Luis Álvarez-Gaumé is Luis, Honor, Harger, our two speakers. Thank you. Our first panel is titled On the Uncertainty of Quantum. And Luis Álvarez-Gaumé is a Spanish theoretical physicist known by many of you at CERN since 2016. Luis has been the director of the Simon Center for Geometry and Physics at Stony Brook. And you left us because before you were at CERN and you've been for many years a great supporter of the arts program. Luis, you received the PhD from Stony Brook in the 1981, and after having faculty positions at Harvard and Boston University, Luis became a senior staff member of the theory group at CERN in the 1988, and he was long-time department head of the theory group. Honor Harger, hello Honor, is a curator from New Zealand with a keen interest in the cultural impact of scientific ideas. Since 2014 is the director of the ArtScience Museum at Marina Sands in Singapore, and is now also the vice president of attractions at Marina Bay Sands. The museum has hosted exhibitions by renowned contemporary artists, such as Theo Jansen or Olaf Eliasson, and explores also scientific themes like particle physics and quantum mechanics. I'm going to leave you to it, and thank you very much for being with us.
Thank you very much, Mónica. Can you hear me? I hope so. Well, it's kind of a big responsibility to be the first one to speak, but I'm kind of introducing the people who really have fantastic slides and fantastic films. Unlike me, I'm a theorist, we don't have a budget, so we have to do things in very rudimentary technology. But I hope that the ideas you will find interesting. Let's see if I can get it, of course, to run. Good. This is the... Now, I want to start with something that at least is an important message that I always like to pass to the general public, or also to people who are interested in science, is that in fact, one of the basic things that change our lives is normally the science that is based on curiosity, not necessarily to solve problems. Curiosity-driven research is the one that has changed our lives radically for hundreds of years. One of those examples is quantum mechanics. If you look at quantum mechanics, it started its formulation or its study in 1900, and by 1925, Heisenberg wrote these famous equations describing the dynamics of quantum systems. But at the time, they were just interested in understanding properties of atoms, the atomic structure of matter. So it had little effect on anything that was going on in the world at the time. Now, it's unthinkable to live today without quantum gadgets. In fact, something like 45% of the US GDP is based on things that come out of quantum mechanics, not only just the United States, everywhere. Transistors, computers, lasers, medical imaging, you name it. So one has to really think that sometimes trying to solve a problem does not necessarily generate the next revolution and the next change or the next paradigm shift that people talk about. At the beginning of 1930, there was the making of the Institute for Advanced Study in Princeton, and the first professors chosen there were Einstein, Gödel, von Neumann, Hermann Weyl. That's not bad. It's quite a good collection of people. But the president or the director, Abraham Flexner, wrote this beautiful little essay, which is called The Usefulness of Useless Knowledge. And that was precisely 5 years after the formulation of quantum mechanics, a defense of pure thought and pure curiosity applied to science. Now, when I was asked to talk about quantum mechanics for a general audience, I thought about this, this motto, this logo that was used in May '68 in France, which is "Soyez raisonnable, demandez l'impossible." This is what they're asking me to do. It's essentially impossible to talk about quantum mechanics, not in 15 minutes, even in 15 years or in 20 years. But sometimes I think it's important not to attach yourself to the words, which cannot describe quantum nature for sure, but to see an image or a set of images. So what I'm going to be doing is to run an experiment. Of course, this is something that you have all seen, which is the interference of wave patterns in water. That's something which you can see by just throwing 2 stones, and then you see that the different circles that are produced begin to interfere, and you get these beautiful patterns of the water going up and down. Now, you can also do that with light. And in fact, there you can see, for example, the case of a laser that is going through a double slit, and then the pattern that is generated on the screen is really a very beautiful wave-like pattern. Now you can ask yourself, well, are these really waves? And this is a very interesting experiment. You can just, this film is 72 seconds, so don't worry, I'm not going to waste your time. It's not astronomy. Isn't that amazing? This is quantum mechanics in your face. This is a film made by these colleagues from Leiden University, which is precisely doing the experiment we were describing before. Well, if I can run this backwards here. But you see, what we're doing is the experiment by taking the laser or the source of light very far. So in a sense, only one element of light, which is normally called a photon, arrives on the screen, and that's the pattern of diffraction. We do not know from which hole it goes through, but it goes through somehow. And then what it happens is that it makes a dot on the screen. Now you put 2, well, you get 1 dot here, 1 dot there. You can't tell where the 3rd one is going to go, or the 4th, on the 5th. These are 600 frames, and what you see is that eventually the pattern, well, I'm not going to repeat it again. Let's try to move forward. Yeah. What happens is that the pattern appears after you see many of these particular photons. Now, what are the lessons that you extract from this? I mean, this is the origin, or one of the basic ideas that motivated quantum mechanics, the so-called the wave-particle duality. Now you've seen it in your face, and you will never forget it. We see that what happens is that particles have what is called localized effects. That's why you see the dots. Okay? But what determines, so what happens is that when you go to the quantum world, you do not lose causality, but you lose determinism. You cannot follow at all steps where each particle is going to go. And in fact, the pattern of where it goes is what is called a probabilistic amplitude. It is that probabilistic amplitude that has a causal behavior and satisfies these Heisenberg equations or the Schrödinger equation. So this is precisely the wave-particle duality, and this is the way, or the reason why you have to give up the notion of trajectory. The classical description of orbits the Newtonian or Hamiltonian mechanics, does not apply in the quantum world. It only applies in this wave limit when you have many objects doing the same thing. So this is something which is interesting, and in fact, we can even extract more conclusions. If you consider some set of quantum systems that are interacting, like two electrons, or several photons, or electrons and protons, and so on, what happens is that these probability amplitudes do not separate between one object and the other. The nice and the nasty thing about quantum mechanics is that the probability amplitude satisfies an equation that involves all the positions of everybody. So you don't live in 3 dimensions. You live in a space of dimension. The amplitude lives in a space which has dimension 3 times the number of objects. And there, the evolution is perfectly causal. And it does not split into a product of amplitudes for each separate object. This is what was called entanglement. And this is the reason why Einstein hated quantum, not hated, but did not like quantum mechanics, because this is precisely this spooky action at a distance, spooky non-locality that looks pretty weird. But nowadays, if you read anything about quantum computing, quantum cryptography, and similar things, it is based precisely on the fact that you cannot separate quantum systems. The Bell states, the Bell's inequalities, all these things are precisely based on this particular simple property. I think that, this is, what am I saying here? Yeah. So in a sense, if you take this even further and do some mathematics, then in 1927, Heisenberg again noticed that if you try to consider, normally what happens is that when you describe a particle in classical mechanics, you have to measure the position and the velocity, and then you use Newton's equations to predict the future. Well, this picture is telling you that this is not possible. There is always some residual uncertainty in the measurement of position and of velocity that is bigger than a certain amount. The minimal uncertainty is what is normally called Planck's constant, divided by 2. That's irrelevant. The world is uncertain because the basic laws of the quantum world are causal but not deterministic. And you just have to get used to it. There's no way out. Einstein is the one who really understood how deep this was in a paper in 1934. It's called the Einstein-Podolsky-Rosen paradox. And as I said, at the time it was very weird. Now, in any laboratory, you go to downtown Geneva or even at CERN or in many other places, you create these entangled states out of which you make qubits, qubits, and as sophisticated quantum computers as you can make. Okay? So this is the simplest introduction I can give to quantum mechanics, assuming that it's not even 9 minutes. Anyway, obviously, this has been 100 years after this. Things have evolved enormously. But still, the basic ideas about this non-separability, the fact that this apparent non-locality are absolutely fundamental. And the consequences are so basic when you put this together with relativity, which is what we're doing at CERN. It explains, for example, why you don't fall into the center of the Earth. That's called Pauli's principle, spin statistics. That's a consequence of these weird properties and adding relativity. Nobody could explain that before. Why, since gravity is attractive, why not the whole Earth does not collapse? What keeps it from falling? Well, it's precisely the fact that you have what is called Pauli's principle, that we are made of protons and electrons, which whenever you put two electrons together, they happen not to like each other. There is a quantum force that keeps them apart. Again, this is a pure quantum force. And that's also what allows you to explain the different stages of evolution of stars, white dwarfs, neutron stars, and so on. This is all based on fundamental properties of quantum mechanics based on this simple picture. Trying to explain this experiment with the right mathematics opens the gate to all those phenomena. All right, so I read my case. By the way, this is a nice picture because this is 1927, one of these famous Solvay conferences, and there you have all the heroes of quantum mechanics. I mean, that conference was held for quite a while. It was always in Belgium. It's very famous. But somehow this is more or less the last one. And this is precisely the year when Heisenberg presented the equation that I wrote before, which encompasses the notion of uncertainty. OK, I raised my case. Thank you.
Well, thank you, Luis, and thank you to Mónica and all of her team for inviting me to speak this evening in this incredibly inspiring location. I'm going to open with a quote from one of the other heroes of quantum mechanics, who said, "What is the source of knowledge? Where do the laws that are to be tested come from? Experiment itself helps us to produce these laws in a sense that it gives us hints. But also needed is imagination to create from these hints the great generalizations, to guess at the wonderful, simple, but very strange patterns beneath them all." So said Richard Feynman, one of the titans of quantum mechanics, the science that we're all celebrating here today. He reminded us that physics is not just about equations, it's about imagining the world in new ways. As you know, here at CERN, scientific discovery does not emerge from experiment alone. Scientific ideas must first be imagined. Every discovery begins not just with data, but imagination. So today I want to insist that art is part of that act of imagination. And I want to argue that art gives us a pathway to scientific understanding. Now, all of this is very important to me because I'm the director of this place here, ArtScience Museum in Singapore. Our museum exists fundamentally to explore the intersection between art and science. We examine that meeting point not to make science more beautiful or more accessible, but because we believe that artists, like scientists, ask fundamental questions about reality. Just as physics seeks to reveal those strange patterns beneath reality, so too does art. We stage exhibitions by major artists who explore science, like Leonardo da Vinci here and M.C. Escher, as well as important figures in science, such as Richard Feynman. In 2018, we staged an exhibition called All Possible Paths that marked the centenary of Richard Feynman. We had an amazing set of scientific collaborators like the Nobel laureate Frank Wilczek to make sure it was scientifically accurate. But we also worked with artists to illuminate Feynman's physics. And that was appropriate because Feynman himself was a visual thinker. His Feynman diagrams changed the way that scientists understand physics. They aren't just a way of explaining it, they're a way of working through it. The artists in our exhibition used visual tools, light, sculpture, and movement to explore quantum physics. Feynman's parton model, for example, imagined quarks inside protons and neutrons at a time where they couldn't be directly detected. A.G. Sumi's installation here reflected this idea, evoking the invisible particles inside an accelerator. Wave is My Nature by Vitol explored Feynman's famous path integral, giving us an uncanny sense of how an electron takes all possible paths before being measured. It shifted between wave-like and particle-like behavior, just as electrons do under observation. As Feynman knew, at quantum scales, the vacuum is far from empty. Fluctuations emerge from nothing. Frederick de Wilde gave form to these quantum disturbances. And this work by Jun Ong, commissioned by the Museum and the Center for Quantum Technologies, explored quantum computing.
That was a field that was inspired by Feynman's 1982 paper, Simulating Physics with Computers, which proposed the ideas that led to quantum computing. Ong's installation simulated a modern quantum computing tabletop experiment where entangled qubits are manipulated to perform calculations that classical computers just can't do. Visitors walk through the piece, physically experiencing how a quantum computer functions. 10 years ago, we exhibited a show called Collider. This was an exhibition designed to bring this world, CERN, to new audiences around the world. Here at CERN, of course, the LHC has allowed scientists to probe the deeper structure of reality, making some of the greatest scientific breakthroughs of recent times. But how do we communicate the significance of something like the Higgs boson beyond the scientific community? And that was the challenge behind Collider, a show developed by CERN working with the Science Museum that we brought to Singapore in 2015. And this was a show made with artists, in fact with theatre makers, who created an opportunity for people to step inside the world here at CERN, to meet the scientific minds who create these amazing scientific discoveries. For our iteration of the show, we ended with The Gift of Mass, an artistic installation that attempted to do something very difficult: explain what the Higgs mechanism is and how it works. The installation placed visitors inside a simulation of a massless universe where particles moved freely, indistinguishable from one another. And as they moved through the space, their presence shifted the environment, symbolizing how the Higgs field interacts with particles to give them mass. Through art, we did something that scientists told us was very difficult indeed. We gave visitors an understanding of how the Higgs boson makes the material world possible. Art brought an abstract aspect of science into the realm of human experience. At the other end of the scale, we've also staged exhibitions about our place within the cosmos, such as the Universe in Art, that featured 120 artworks and scientific artifacts from around the globe and through history, including scientific manuscripts by Galileo and Newton, as well as contemporary artworks that examine modern ideas within astrophysics that challenge our intuition, just as quantum mechanics does. Mariko Mori's artwork visualized a recent idea in cosmology that suggests that the universe may not originate from a single Big Bang, but an endlessly repeating cycle of beginnings and endings. Andreas Gursky's Cameo Candy captured the cathedral-like grandeur of a neutrino detector in Japan, an instrument that allows us to perceive the ghostly particles that are neutrinos passing through space and time. And if neutrinos are hard to detect, then this artwork by Conrad Shawcross focused on something even more elusive: dark matter. It was inspired by an idea from Dorothy Hodgkin, who said that trying to determine the structure of a molecule from X-ray crystallography is like trying to work out the shape of a tree from studying only its shadow. Now, this is exactly what astronomers do with dark matter through a process called gravitational lensing, inferring the shape of something unseen by observing how it bends space. Gravitational lensing is one of those ideas, a bit like the Higgs mechanism or Feynman's path integral, that's hard to explain, but possible to sense through immersive art installations like this one. We returned to space in a recent show about the planet Mars. It synthesized 12,000 years of cultural history about Mars. And artists were key to communicating some of the most challenging ideas in the show. including The Moment by Katie Patterson. At first glance, this looks like a simple hourglass, but inside is something special. Fragments of the universe older than the sun. This is material from dying stars, asteroids, and Martian meteorites spanning millions of years. Katie invites us to pick it up and feel it, to turn it in our hands and experience deep time as a physical presence. Katie wants people to physically understand their own connection to the vast timescales of the universe. Here at CERN, you reveal the fundamental structure of reality. The discoveries made here are extraordinary, but they're also counterintuitive. They push against the limits of human perception. They challenge us to imagine realities that can only be inferred. Richard Feynman also once said, "Our imagination is stretched to the utmost, not to invent things that aren't there, but just to comprehend those things that are." And this is where art can play a role. Not by simplifying physics, not by making it beautiful, but by helping us think through it. The examples I've shown today engage with physics by helping us sense it, to make its strangeness feel real. Science describes the hidden architectures of the universe, and I believe that art, like physics, is a way of revealing it. Art helps us imagine quantum physics more deeply, because, as Feynman said, also needed is imagination. Thank you. So, Louis, now we have to have a discussion.
I guess.
And I'm really...
Well, your pictures are better than mine.
But your pictures and mine are so connected, I think. I'm intrigued by an idea that we've discussed in our conversations around why quantum mechanics is so counterintuitive. And I think you have a really lovely way of explaining that.
Well, I'm not sure if it's lovely, but the idea is the following. I mean, in principle, we all have an understanding of classical physics. Forces, vectors, motion. And this is something that is ingrained in your brain, or hardwired in your brain, thanks to evolution. You need that to survive. We never needed quantum mechanics to survive. We've only known quantum mechanics for 100 years. So it hasn't had enough time to be ingrained into the evolutionary process. So it's a nature that, I mean, of course, the world has been quantum since the very beginning. It's just that we didn't notice until 100 years ago. But in the meantime, you see that all mammals and all animals have a fundamental understanding of classical physics. Mm.
And one of the things I was really struck by in your presentation is flashing up the 1927 conference at a time where, you know, physicists were really trying to grapple with what this concept of uncertainty really meant. Mm-hmm. So what does it mean to you now today, working as a theorist 100 years later?
Well, I don't know. I mean, this thing about uncertainty, makes some people a little scared and so on, but it's just part of life. The problem is that one thing that one has to is that when you see experiments, and when you try to do experiments and see the behavior of the world under these conditions, we also have a mathematical description that goes beyond our intuition. You know, without the equations that describe this particular world, it's very difficult to have an intuition of what's going on. And I would also go further, is that somehow we rarely understand things deeply. We get used to them. Yeah. So after you repeat experiments and you see some patterns repeating, then you feel comfortable with some behavior. But understanding it deep down is, in general, not so easy.
So it's almost like you form intuition over time by repetition, practice.
Precisely.
And do you feel like art can almost kind of play a role in helping kind of form that intuition?
Well, that's where creativity comes. I mean, the thing that sometimes we are imagining some quantum worlds with additional properties, like people who think about supersymmetry, supergravity, string theory, and unfortunately, nature for the time being doesn't want to be nice to us, because in principle you cannot just second guess what nature is going to be doing. Look, I mean, quantum mechanics is our bread and butter, unless you do some very specific thing about, I don't know, the three-body problem in astronomy. So you just get used to it more than anything else. Now, deep down, for example, there are numerous discussions about the interpretation of quantum mechanics. And there are many philosophers, even theologians and physicists who discuss about the meaning of all this, what the uncertainty, the so-called the collapse of the wave packet, and this and that, the many world interpretation. Our former colleague John Bell was worried about these things at the end of his life. He was really very worried. But Dirac, which is one of those people that appeared there, one of the great geniuses of the 20th century and also many other centuries, one of the fathers of quantum mechanics, wrote one of the best textbooks on the subject. And somebody asked him, Professor Dirac, you never mentioned the collapse of the wave function. He said, well, it's too early to solve that problem. It's still too early. There are aspects of the theory that we haven't understood. There are many aspects of the world that should be quantum that we do not understand, like the origin of space, the origin of time. These are things which are emerging properties of a quantum structure that is much more fundamental than what we have now. You can do this. These are phonons. These are the quantums of sound. To understand this, you really have to understand deeply, you have to understand the atomic structure of matter, because the vibrations and so on. Well, we do not know from which substructure you do like this and space and time appear. So this is one of the places where somehow nobody has a clue. There are all kinds of theories with string theories, with loop gravity, so you name it. But we still have not understood what the problem is. And one of the reasons is that we cannot probe nature at the scales where space and time break. So, I mean, pure thought is very helpful, imagination is very helpful, but sometimes we're not that smart. And nature normally outsmarts us 100 times or 1,000 or 1,000,000,000 times. Like, space and time, for example, are very different. Just excuse me for I speak too much. Although special relativity tells you that there is the unification of space and time, the space-time continuum, notice that there is a huge difference. I can measure this table now, and now, and now, and tomorrow, and yesterday, but you cannot measure yesterday more than once, which is when you live through it. That's a huge difference. In fact, in quantum mechanics, there are operators that represent space, distance. There is no operator that represents time. We don't measure time, we count it. That's why we value good clocks so much. So even the origin of time is something that, although, in fact, when you do relativistic physics, like in the LHC, you think about, what are the objects that you look at are somehow objects that create and destroy particles. And those processes are described by 4 parameters, which is where that happens. Those parameters are 3 positions and 1 time. But you abandon the notion that there is an operator whose eigenvalues or whose values corresponds to time. So even though we have a causal structure with relativity and so on, something as simple as this, we do not understand. Why you can measure space as much as you like, and you can only live through time without ever measuring it. Eventually, maybe some theory more fundamental than quantum mechanics will tell us, because we need to describe causality, the fact that time is unique in describing how we go towards the future.
And as a theorist, what are some of the emerging theories that you're excited by that might, can it help us start grapple with this?
Well, unfortunately, string theory made many promises, but it has not delivered. And most of I think we're just, some of these theories are crazy, but as Bohr would say, they're not crazy enough. We haven't really had the right, in quantum mechanics, it was far more difficult than inventing relativity. I mean, there's just no comparison between the complexity of quantum mechanics, at the level ideas, and general relativity. But at least they had experiment. Yeah. Einstein thought of all of it in his head. In fact, I think it's important to realize that nature or the laws of nature are unavoidable. They can happen in the head of a single man who was extreme genius like Einstein. But even if Einstein had not existed, as soon as you try to put a GPS system, it would have gone out of step in a question of minutes. And then you have understood that, in fact, the running of clocks will depend on the height on the Earth. So it depends on the gravitational attraction. So eventually, a dumb group of thousands of physicists would have actually formulated quantum mechanics, special relativity, or general relativity. Quantum mechanics is very profound, but the advantage of the forefathers is that there was experiment. And at the end of the day, experiment is the oracle, where you ask questions. Sometimes you don't understand the answer. We do not have experiments that tell us about the nature of time or space at the deepest level. All we have is extrapolations of the theories that work with quantum electrodynamics, with QCD, with nuclear physics. But, I mean, something more basic out of which emerges space and time is something which nobody has thought about.
Which feels like a beautiful note to end on. Like, we're still uncertain about the fundamentals of space and time. So what better moment to kind of segue out of this session and into the next.
Absolutely.
So thank you, Luis.
No, thank you.
Thank you so much. This is
Thank you.
brilliant. Wow, very inspiring. So our next guest,
The clicker is there.
speaker,
The clicker is there.
is going to read this poem. Holly Corney Carr is a poet based in Bristol, UK. Her writing explores the space and languages of holiness, from caves to the pigment speed of a fly's eye. Previous work has won the Free Writers' Prize and the Society of Authors Eric Gregory Award, and she has made poems, books, and performances for the BBC, the Highworth Gallery, and the National Trust. She is a lecturer in poetry at the University of East Anglia. So, you are here. The stage is yours.
Thank you so much, Mónica, and thank you, everybody. And I'm so pleased to have come onto the stage just after the idea of the oracle was raised. I'll talk a little bit more about this in my essay, which I'll read to you. But the oracle as being something that classically we thought of as being in a cave, a voice that we could visit to ask questions and receive answers. And I'm thinking of CERN as a cave today. At the same time, elsewhere, or perhaps here, something toneless, and at the same time, elsewhere, or perhaps here, this poem. I'm here to talk to you about making a poem and what we might unmake in the process of making a poem. Poets are always reminding each other that the word poetry arrives out of an ancient Greek word for making, and that the poem is, at least etymologically, if not etymologically, a made thing. And I arrive here also out of a long project where I've been thinking about and writing about poets who, in one way or another, dug themselves into holes in order to make their made thing. Initially, my interest in this was in asking why. Why would a poet climb down into the echoing dark of a hole or a cave or a tunnel to make their work? But there, in my question, was something of an answer. In the echo of a hole or a cave or a tunnel, the poet is able to perhaps double their voice, is able to enter into something of a conversation with themselves, is able to ask, and perhaps in listening carefully, answer the question they came with. In the dark, the poet is able to enter into a kind of light, but light isn't right. It's not the absence of the dark that the poet goes into the hole or the cave or the tunnel looking for, but something more like perhaps the echo of the dark. There is a correspondence between absence and presence that we recognize. And so in thinking I know how that correspondence works, I called it light. But I have in mind the romantic poet William Wordsworth, who talks of dazzling or bright caverns, or perhaps the modernist poet H.D., who stares into the bright portal of a dark granite cliff face. And I'm wondering about that idea of a bright dark. Is bright dark a roundabout way of saying light? Or is bright an intensifier, a bright dark, a kind of double dark? I'd been concentrating on the hole in the ground as a way to think about loss, perhaps, memory, and ways of thinking about hope, ecologically, politically, personally, and that way of looking that tells you that for every hole, there must be at the same time, elsewhere, or perhaps here, a hole-sized amount of matter, material which by rain or claws or explosives has been removed in order to make that hole in the ground. And what did it mean for the poet to be entering into this place, this arrangement, this experiment in correspondence. And when I say correspondence, I'm thinking of it not just as a mode of writing, that way of writing between me and you, but also as a model of that peculiar correspondence of the bright dark, the double dark. In 1965, the poet Ian Hamilton Finlay is writing to another poet, Ernst Jandl, about a hole that he's been digging. And it's the second of 2 ponds that he's installing in his garden, where he's also installing a series of sculptures. And along with the photographs of the sculptures, Finlay promises to enclose with his letter to Jandl a picture of the pond strewn with fallen apples and leaves and its reflective surface scribbled over by beetles. He makes this promise because, and he adds this bit in parenthesis, the pond too, that is another poem for me. And for me too, this idea of another poem imagines that there might be a primary poem to which the pond's form and mass and beetling energy must correspond. But if a pond might be another poem, I'm compelled to trace this strange symmetry, certain that if the pond and the poem share something with each other, it's in the way that the pond is a whole and it produces a whole heap of soil in its making. There is the pond, and there, just beside it, is the heap of soil, the sort of not pond. But in his letters, Finlay doesn't talk about the pond as an empty space, and he doesn't talk about the poem as its opposite positive heap. His interest rests on the pond's reflective surface, the way it opens a portal to the sky, the way this one round body of water speaks to other bodies of water. And my perspective tilts, and I become distracted perhaps by those correspondences then of evaporative waters, of rain, of sea, of rain again, of still trying to locate this another pond reassembling somewhere else. And for a time I lie at the edge of this imagined pond, surveying the imagined shadows of the imagined clouds in the bright sky and the dark waters. But there is something in the language that physicists use to write about their experiments in the bright dark that tells me I need to go about my search for another poem in another way. In the theory of supersymmetry, which predicts that for each particle in the standard model of the universe, there is a partner particle, and the naming system adds a prefix of an S to that partner. Supersymmetry predicts that there might be an S particle, a sparticle for every particle, a selectron for every electron, a squark for a quark, a mirror that switches sup and stown, and everywhere a darker strangeness at work alongside our own known strangeness. And it was after learning this that I began to listen for a voice in the stark. Such a theory anticipates a half of everything which at this moment in time we can't quite understand or know, or perhaps we can't quite understand or know. The terms of symmetrical thinking are themselves quite hard to grasp. Their weathers move across the horizon like seasons for me. But back at the edge of the pond, I begin to seek a symmetry in everything, coming to think of the poem as another pond, another poem as the pond, another pond as the poem, until I arrive at the possibility of the spoem and the spond. The spond isn't the pond, and it isn't so straightforwardly the not pond either, that heap of soil piled up next to the pond, or those time lapse of future ponds, the droughts, the floods, the droughts clouded over, but instead it's something else, and it glitters bright and dark and double. And I had, before I knew it, recognized the outline of the spond elsewhere. I saw it in correspond, and this spond is made of language. It isn't so similar to the garden pond, but it's perhaps closer to that idea of similarity itself, that same similarity that means a poet can look at a pond and see another poem there, something mutual, something shared. And the word correspond itself is assembled from the Latin com, for together, for with, for between you and me, between one thing and another word, respond, another word for answer, where the re might modify the spond in 2 ways, perhaps. Somehow it's both a return and a repeat at the same time. The re is to go back and also to go back over. The same thing. We might regret, we might recover, we might rebuild, redeem, rest. But it helps me to imagine that in each of these forms of answer, they contain that fragment of uncertainty. Am I doubling back or doubling down? Am I changing or making up my mind? There's only one other place that I start to see the surface of the spond twinkling, and that's in the word despondency. And the word despondency and losing heart and losing hope, that's where the spond comes most clearly into view for me. As a part of other words, the spond is a promise. That's its etymological root, at least it's a promise. And we find it survives still in words like sponsor or spouse. If the spond is a word, it's a word for a kind of partnership, a promise. And here is the mutualism and the care of correspond, in the answering voice of respond, in the loss of despondency. The spond, I guess, is a way of saying I hope, I have hoped. And the same spond works this way into a technical label that poets use, a spondee, and we use it to describe the symmetry between two sounds or two syllables, two partner particles of a poem which bear equal weight within a word or a line. Students of poetry encounter the word in textbooks, but we often encounter it, most often rather, in the feeling of it, in the chants or in prayers, like see, saw, elsewhere, something, concrete, unmade, vacuum, unknown, artist, hopeless. But the word poem itself is not a spondee. For some people, perhaps the first syllable might land a little bit more heavily than the last, while for others there can only ever be one syllable. We get that initial revelation of the O, and that glides in an instant into doubt. The word poem is either o, or it's om. And that latter version might be a diphthong, a way that one vowel can transform into another, all in the space of one syllable. But in that way of speaking, the two syllables collapsed into one, that resulting poem articulates something perhaps about the way the bright dark, the double dark, that suspension of belief and disbelief, and by suspension, I should say, I'm thinking of a kind of amicable solution, and by solution, I'm thinking of a kind of answer, the kind of answer I find in a poem, that I find in a poem, that I find in a poem. When poets are not reminding each other of the work of poem making, they might brush their shoulders down, they might put their tools away, and they speak to each other about negative capability. This is the poet John Keats's term for being able to tolerate being in uncertainties, in mysteries, in doubts. In a letter written in 1816, Keats describes negative capability as an acceptance of a half knowledge, a model of uncertainty, which implies another half that's always hidden from view. That shadow half is located in what Keats imagines as a most holy location, a penetralium or innermost chamber of mystery. And he absolutely discourages other poets from setting off in search of it. Would some or all of its mystery be somehow unmade by the poet's arrival, or would that hidden half not survive the return to daylight? I've been preoccupied by the correspondence of the poem with the spoem, the pond with the spond, what is made and what is unmade by writing a poem. But perhaps the poem, that engine of uncertainty, opens a space between what is unmade and what is sun-made. These correspondences for me have the magic of perhaps the anagram. Their symmetry is transposed over some oblique angle that I can't quite measure. But in their form and their mass and the material, they correspond. They share half knowledges with each other. That bright dark doubles the other. At the edge of the imaginary spond, turning the poem and another poem and another poem through this supersymmetric language game, I imagine the grand experiment of perhaps a double negative capability. And I don't mean for this double negative to be resolved into a positive, like the heap of soil, like the storm clouds gathering, but to find out how to enter into this suspension of halves and wholes, and to finally learn how to speak with that voice in the stark. My voice comes back to me as an echo. At the same time, elsewhere, or perhaps here, something toneless and wordless. At the same time, elsewhere, or perhaps here, the poem. Thank you very much.
Thank you, Jalal. Thank you, Mónica, for this great invitation to return to CERN after a span of maybe 5 years. And it's wonderful to be with you and to have listened to all that has gone on before, because it kind of makes my task easier, because in the first panel, you already laid down the foundations for what I know nothing about. And I'm speaking from that position of knowing nothing, which artists can claim as their birthright. So, making bets while knowing nothing. Let's hear it from the man we've already heard so much from, because he says it so much better than any of us can. I'm hoping this... Oh. This is supposed to come on when I press the... See, I know nothing about this. Yeah? No. Yeah. So... The what, sorry? No, I was told that the one on the top is what you need to do when you have a video. No. Okay, we'll do the one in the middle. No, that's what happens when I do the one in the middle. This is like becoming like a quantum mechanics experiment. Anyone here? No. Yeah, so this video is supposed to be if I press this button, right?
This is starting, is not automatic.
Okay.
Yes, I will start.
Okay.
You see, one thing is I can live with doubt and uncertainty and not knowing. I think it's much more interesting to live not knowing than to have answers which might be wrong. I have approximate answers and possible beliefs and different degrees of certainty about different things, but I'm not absolutely sure of anything. And there are many things I don't know anything about, such as whether it means anything to ask, why we're here, and what the question might mean. I might think about it a little bit. If I can't figure it out, then I go to something else. But I don't have to know an answer. I don't feel frightened by not knowing things, by being lost in the mysterious universe without having any purpose, which is the way it really is, as far as I can tell, possibly. It doesn't frighten me.
Okay, I could just stop here and go back to the seats, right? Because I think he says it so beautifully. But I also like this woman from the 16th century in my part of the world who also kind of said it beautifully, Mirabai. She was a princess, a rebel, and a mystic. And she has this beautiful song, because she wrote songs, and says, knowledge is a game, dice roll, players rise and fall, but the world declares all bets are off because victory is defeat. Good Lord, she's addressing God, be wise, your knowing days are numbered. So before Einstein protested it against God playing dice with the universe, Mirabai said, God, even you don't know what the universe is all about. So we don't have to know either. And it's a celebration of that not knowing that I think is the most pertinent thing for me as an artist. And that's why I'm here at CERN, because I don't know what you do, and I'm trying to find out. What would happen if one placed a bet on the idea that knowing nothing, the knowledge of nothingness, is the basis of wisdom? This is actually not a very new idea, despite Richard Feynman, even though it remains a surprising and unsettling one. Recognition of nothingness or emptiness, or what we call shunyata, is at the very heart of an ancient way of knowing and acting in the world. So not knowing is a way of knowing and acting. It expresses a gentle skepticism about three complementary proposals, familiar to us from both one kind of natural science, let's say classical physics, 19th century, till quantum mechanics came up, and some forms of theological doctrine, namely the assertion that the universe is either one totally knowable thing, that's what Newton helped us get into grips with, or that the self is coincident with the cosmos, which is part of a lot of mystical doctrines that state very, very confidently, you are the universe. Actually, I'm not so sure. I don't know if I am, right? Because to be self-aware then in those traditions is to know the universe. Or that actually everything is just random, pointless, and chaotic. Because that's also a position of certainty. And I think that what happens with quantum mechanics is something quite different. It's not saying everything is random. It's not saying things don't have a cause. It's saying we are not always in a position to be able to determine things. We can see patterns, we can see probabilities, and those probabilities and patterns are not certainties. And let's be okay with that. There is a fourth way, and that consists in knowing that the primacy of nothingness is a binding principle, that a sense of emptiness, the vast emptiness, as I've been told, of the proton itself, is an awareness of its generative substance, form, and knowledge. In some traditions of knowing and acting in the Asian universe, including classical Madhyamika Buddhism, and some common forms of knowledge and spiritual questioning, this would be called a formless or nirakar awareness. The insistency on the primacy of nothingness is not an admission of ontological failure or epistemic collapse. Rather, it's a recognition of the fact that what binds one thing to another cannot be easily named, marked, or numbered. Its existence is not signaled by its substantiveness, but by the way in which its massive immateriality affects other things, like the way the black hole affects your astronaut who's falling, and that impossible photograph that you talked about. So what does it really mean to know nothing? This is part of a work of art that my collective did, was to try and touch a meteorite that's actually older than the Earth, that we found somewhere in the Arctic Circle. And touching it, because it comes from the asteroid belt between Mars and Jupiter, but it is at least 500 million years older than the Earth, makes you think about scales of time that are frankly so large. I know that they don't seem so large here, but for me they seemed quite large, that it was interesting to think of the fact that the Earth contained an object that was older than itself, and that paradox that you could host, the planet could be a container for something that was older than itself, which is actually, quite a commonplace thing. The planet is a container for all these atoms, protons, electrons, neutrons that are actually older than itself. There's some carbon in me that's formed somewhere very far away outside the solar system, maybe even, and that's older than me. Now that paradox of being composed of materials that are older than the planet we're on is again something that one has to turn one's head around. Which takes me to different ideas of understanding time. Everyone's talked about Feynman diagrams. This is a beautiful picture of Feynman doing a lecture at CERN in 1970, trying to talk about time. And he's talking about the fact that in what is known as the Feynman-Stuckelberg interpretation, antimatter, of which you have a factory here, is identical to matter but moves backward in time. A negative energy particle which propagates backward in time, or equivalently, a positive energy antiparticle which propagates forward in time. So if we are talking about that little bit of matter that is left over from the annihilation process between matter and antimatter that happened just after the universe, out of which we are all built, that little residue, that obviously means that there is a forward direction in time that's happened somehow by I don't know why, and that there is perhaps all the antimatter particles are moving backwards in time, I dare say, to a universe before the Big Bang happened. Maybe, I don't know. But that's not, that's what I love doing, not knowing, right? Yeah. So that's my colleagues in the Raqs Media Collective, Jibesh Bakchi and Mónica Narula, trying to find some matter just outside the antimatter factory. There was a lot of it. But that meant that we started thinking about time, which is a fundamental idea in our practice in Raqs, quite differently. And I think that the invitation to spend those few days at CERN really radically changed the way we think about time as substance, as something that moves us and that we move around when we play Play-Doh with it. And walking within the corridors. That's Mónica, Jibesh, me, and Mónica. We have two Mónicas. They're not antimatter and matter. They did not annihilate when they collided, but they were quite, nice to each other. So two Mónicas, one Shuddha and one Jibesh, in the tunnel below, trying to understand the meaning of life. Which means that you constantly, and the tunnel itself is, and today I got lost trying to come out of the main building because it's such a labyrinth, right? You never know, you have to climb up a staircase, get out of a glass door, and you don't know where you're going exactly. So, which is a lot like trying to understand the nature of matter and antimatter. It's labyrinthine. And I was thinking of Jalal's really beautiful evocation of the labyrinth of ruin, where a ruin becomes instantly ancient, so it sort of folds in on itself. And he talks about Baalbek, a place that I really love. This is when, again, the Raqs Media Collective was wandering around aimlessly in Baalbek in Lebanon, chasing, in a Wordsworthian sort of way, some floating cloud, with a labyrinth inscribed on stone, right? And this twisting, turning way of thinking about life and matter and time is something that I, as an artist, can claim some luxury for. So, if you read Jalal Toufic, he says that the archaeological ruins of Baalbek exist in an anachronistic, labyrinthine temporality. But he's not talking about Baalbek. He's talking about an apartment in Beirut destroyed by the Civil War. And once destroyed, it becomes as ancient as anything can be, because all ruins become instantly ancient. And the effort to restore them is an effort to sort of negate their instant ancientness, their passage into a different kind of uncertain time. So, 100 years, right? More or less, depending on, of course, we're uncertain. Is it 27? Is it 1925? Is it 1934? Is it 1900? But let's, for a moment, say we don't know the momentum, but we know the position, and we are going to say it's 1925, right? And it's this young man, Werner Heisenberg. He's got hay fever, so he has to escape to this little island called Heligoland. And as he said, it was about 3 o'clock at night when the final result of the calculation lay before me. At first, I was deeply shaken. I was so excited that I could not think of sleep. So I left the house and awaited the sunrise on the top of a rock. Here he is at CERN, decades apart, 1961, 1971. 71, he's, I think, inaugurating, I may be wrong, he's inaugurating a part of the tunnel. The pipes have just been, or some pipes have been laid. So here he is chasing these particles still after all these decades, right? And that's what we learned about earlier this evening. And the letter X indicates the position of a particle. The letter P indicates its speed multiplied by mass, what we call momentum. But it's an incredibly simple expression, so that even someone as stupid as me imagines that I can actually understand this. Because ultimately, it is a really simple expression. Position multiplied by momentum is not equal to momentum multiplied by position. Normally, in the arithmetic we learn at school, when you multiply two things, and if you repeat that multiplication in the different order, they should be the same. 3 into 5 should be equal to 5 into 3. But here something else is happening. There's something remainder, there's something residual that's kind of obstinately saying, look, I am this strange H with a cross over it. And that's what you get when you multiply position and momentum. And its formal simplicity contains within it its immense obscurity and its opaqueness. So a single equation of 8 characters in classical physics, an equation that says that this opaqueness is a complete stab at a complete description of reality. That's Carlo Rovelli, who's such a beautiful writer, and from his book, Helgoland. It's not accidental, and this is for Jalal, that Helgoland is the place where Nosferatu, the vampire film, was shot by Murnau 2 years before Heisenberg gets there to escape hay fever. So maybe there's a vampire that's inducing these dreams about, what's position and momentum and what's the ghostly remainder of this calculation. Just to say, Jalal, there be vampires there. Okay. 100 years of uncertainty? 100 years of uncertainty are better in the long run than a day of being certainly wrong. I'm comfortable with that. I'm comfortable with 100 years of uncertainty. Oops.
One of the surprises offered by the sky is that the constellation called Indus is most visible from the southern hemisphere. Parallax makes viewing it impossible from the land of its namesake. A star is but the imprint of light over time and space. When the time scale is so brief that it is both history and the present, parallax should be defeated. And yet, seeing things from there changes what the thing is when seen from here. The ribbon of a year that knotted the decades before it turns liquid, slippery, mercury. (1980) A parenthesis. A bracket that opened to include one duration, closed to exclude another, and in between, an uncertain passage.
An uncertain passage. 1980 is a year in which almost nothing happened. I was on a bicycle. I saw a plane fall from the sky. The plane contained the man who wanted to be India's dictator forever. He died, and we were given a little bit of respite. It was an accident. But it was one of those strange situations where gravity and a spinning plane and a crazy dictator wannabe conspired together to create a certain passage of time that gave us a little breathing room. I like to think of 1925 as a year a bit like that, right? Where it's still possible 2 years later for all these people to meet at Solvay before Europe goes up in flames shortly after. So it's one of those strange situations where, like CERN, you have scientists from all these countries that might be fighting wars, but they have more important work to do, like find out how many protons they can get to hit with how many other protons. It's in that uncertain time where nothing happens that you can actually get a sense of what might be happening in very distant and larger timescales. It's in that uncertain time that matter can be haunted by its absences. So here, for instance, is a work by us, which is a ghost of an abandoned railway station somewhere in northern Japan, where we could say, is the railway station in superposition with its flying away spirit? Maybe. But the point is that here is matter trying to take off and levitate from the ground and light up when actually the twilight hour of uncertainty comes. Or you could then think of clocks that cannot measure time. They can just rotate endlessly, but there is nothing for them to measure. Like we saw just now, you can measure the circumference of a table. But how can you measure yesterday? How long was yesterday? It was 24 hours, but did it feel like 24 hours if you were sick with malaria? Or did it feel like 24 hours if you were on a plane? Do those two temporalities correspond to each other? Or what is contained in a box when it is shut, and what is contained in a box when it's open? We know that forever from that unfortunate cat, which, we've heard so much about. This is from a work that we did, which is a time capsule. It's interred somewhere in the ground. And it just says it's waiting for a young girl who is 4 years old to be 54 years to be actually talking about what the time of her life will be. What does it mean to contain infinite infinities, for instance? I'm going to end by showing you a few pictures from the time that we were here at CERN. This is a blackboard, and this gentleman was trying to explain to us what relationship Maxwell's equations in electromagnetism have to do with the search for quantum mechanics. And they have a lot to do, because there's certainty, and then if you do the mathematics differently, you get some kind of uncertainties. And there's something interesting in this blackboard, which is, you know, in the place that, oops, sorry. Yeah. What he's hiding is this goblin that somebody has drawn on the blackboard while he was, or before he was, you know, writing Maxwell's equations. And that goblin is perhaps what John Bell was searching for all his life, the strange paradox of non-local action, like that strange entanglement between here and somewhere very far away in the universe, which produces that strange thing called spooky action at a distance. Why am I even talking about it? I'm talking about it because we are all here spookily. We're not local. This place is a claim on global significance. We're living at a time where we are constantly asked to return to some form of locality. You know, put higher borders around our territories, make it more difficult for people to travel, make it more difficult for scientists to come to CERN and work here, when one of the realities that John Bell showed us, because he wrote this beautiful essay on a man with two kinds of socks, that you don't know what one foot is doing, what color socks one foot is wearing, and what color socks the other foot is wearing. I wear mismatched socks all the time, because I am not able to be local. I'm not able to converge all my socks in one place in a drawer. And that's really important, because in the arts, in sciences, to argue for non-locality, to argue for entanglement, is something that we absolutely have to do right now. I'll end there. Thank you. Oh, maybe I'll end with this. It's John Archibald Wheeler quoting Gertrude Stein, telling us what science is and what quantum mechanics is. It looks strange, and it looks strange, and it looks very strange, and then suddenly it does not look strange at all, and you cannot understand what made it look strange in the first place. So you get used to its strangeness. Thank you. Yep.
I'll ask questions about the video we saw. Time cone, we have light cone in physics.
Yeah.
Is there, what kind of relation are you doing there? And reflections in the water without the actual bodies. Can you talk about this?
Sure. We're famous rogue scientists. We have no claim to being scientists, but we pretend to be in Raqs. And that gives us the freedom to actually think about concepts in deliberately clumsy ways. So a time cone could be something like a light cone, but made out of time. So you could, for instance, the year 1980 could compress to a year in which almost nothing happened. And then from the position of the person on the bicycle watching this plane fall, suddenly time could expand again. So it's that idea of the contraction and dilation of time factored in through experience that I think we were trying to think about. We didn't write a paper. We could have sent it to, physics or something like that, but we made a short film. And it was our claim at saying that we can think about time factored in through experience and memory differently so that it contracts and expands when we think about history. Reflections are because, matter and antimatter, as you said, are things on two sides of a mirror that sometimes look at each other and then look away and don't recognize themselves. Because if they did, everything would go crazy. Okay. I have a question for you, which is about the photograph of the astronaut falling through the black hole. Because it captures for me a possibility of, if, for instance, falling through the black hole were to be a viable means of travel in time, which sometimes I'm told it is, then could we go back to the very beginning of the universe, that 380 odd million years when there's no light even, when it's completely dark, when the first stars haven't happened? Can we have a photographic nostalgia for complete darkness as a form of radical closure?
As long as we have black holes, and my layman's knowledge is not sufficient, but if that's the border where we can say photography in a certain sense of immobilization and flattening of what is approaching it is present in the universe. So the stress in the text in part is we didn't invent photography, or we invented it in a way because it's already present and we're trying to actualize it in our own manner. I just, since I mentioned an apocalyptic photographer, so as the astronaut approaches the black hole, if we consider that he is a monad, and the monad in Leibnizian philosophy expresses the whole world. The whole world is implicated in the monad. So as he approaches, I would say, this enfolded world begins to unfold. And so it's in this sense that it's an apocalyptic moment, because the world is in the monad, and as the monad approaches, you see more and more of the universe unfolding from the monad. And I think that's an interesting situation.
So it might be a deflection away from the apocalypse.
It is the apocalypse.
Okay.
Apocalypse in the sense of revelation. Okay. You're seeing the whole universe unfolding from this monad approaching it.
Okay, on that note, I think we fold. Thank you.
Thank you, Shuddha and Jalal. Our next speaker is Rasheedah Phillips. You are welcome to the stage. Rasheedah is a queer housing advocate, parent, writer, interdisciplinary artist, and cultural producer. Coming from LA, she has been with us for a number of times. It was an honor to have you. And she is now presenting a book based and inspired by the residency called Dismantling the Master's Clock on Race, Space and Time. Thank you, Rasheedah.
Thank you. Thank you so much for having me. It's always amazing to be here. I'm going to read just a brief excerpt from my book. The very first chapter is about my time at CERN. That's how amazing and inspiring it was, but I'm not reading from that chapter because it's going to be a bunch of stuff that y'all probably already know and have heard about, so I'm not going to talk about that. But I'm going to read a little bit from my second chapter. So in the African American folktale, Brer Rabbit's race with Brer Turtle, Brer Rabbit, confident in his swiftness, agrees to a race. Yet in a clever twist, the turtle enlists his family members to aid in an elaborate ruse. By dressing each family member identically and positioning them strategically along a path marked by hills and valleys, the turtles create an illusion of continuous progress. Each time Brer Rabbit encounters a turtle ahead of him on a path, it seems as though Brer Turtle is perpetually in the lead. This culminates at the finish line where the real Brer Turtle waits, appearing to have far outpaced the rabbit. This loop of misdirection contrasts starkly with its classical counterpart in Aesop's fable of the tortoise and the hare, where the hare's laziness leads to his downfall, which imparts a moral of steady diligence over swift complacency. But instead of valorizing individual speed and linear progress, hallmarks of the Western arrow of time, in the African American folktale that I just summarized, the turtle employs a strategy of collective effort that disrupts the linear narrative. That multiple temporal events can coexist and influence each other exemplifies the cyclical and relational conceptions of time and of success as the product of collective support and shared wisdom. This folktale reflects Black and Afro-diasporic temporal forms of consciousness that are deeply ingrained in processes of community, nature, and the cosmos. Karen Berard's theory of agental realism offers a compelling framework that aligns with that sense of unity, of collectivity, and of reality as integrated. Karen Berard suggests that entities, including humans, do not pre-exist their interactions. Instead, they emerge through specific intra-actions, a term that Karen introduced to signify the mutual constitution of entangled agencies. This notion challenges the classical view of independent, pre-existing entities that interact in a linear cause and effect fashion, proposing instead that phenomena, including the entities and their properties, emerge from these intra-actions. Drawing from Niels Bohr's quantum mechanics interpretation, agental realism proposes an ontological perspective where the universe is comprised of phenomena that are indissolubly the product of intra-acting agencies. This paradigm shift from interaction to intra-action emphasizes a reality where boundaries and identities are dynamically co-created with an ongoing network of relationships. During the summer of 2013, when I was researching my first self-published book of speculative fiction, Recurrence, Plot, and Other Time Travel Tales, I encountered the acronym CPT, which stands for Charge, Parity, and Time, and is a cornerstone concept in physics. As I stared at this acronym written in my notebook, my mind immediately flashed to an alternative CPT, one that I was all too familiar with, which is colored people's time. This term, often used derogatorily, implies a perpetual shared lateness among all Black people, a stereotype long wielded against us. This link reinforced my understanding that time is not only a physical dimension, but it can also be a deeply inequitable social construct. My collective project, CPT Symmetry and Violations, was an exploration of those varying scales and dimensions of time and temporality, spanning from the particle to the personal, to the interpersonal, to the communal, to the global, to the cosmic. Through that project, we wanted to extend a dialogue between the quantum realm and everyday realities. By intentionally paralleling the scientific concept of CPT with the culturally significant notion of colored people's time, the project aimed to confront and deconstruct racialized perceptions of time and punctuality that have historically marginalized, stereotyped, and oppressed Black communities like the ones that I come from. This approach bridged the often esoteric, if you want to say, world of quantum physics with the palpable realities of race and space and time, implying the potential to break from conventional linear perceptions of time that have, again, historically marginalized Black communities. And in this light, quantum physics becomes a prismatic lens through which we can reimagine time itself, not as a rigid inexorable flow in a predetermined forward direction, but instead as a malleable dimension, open to reinterpretation and open to transformation. And such a shift in understanding time has significant corollaries, not just for science, but for addressing the sort of social inequities that I deal with as a lawyer and as a housing advocate. If time can be perceived differently at the quantum level, if there is a symmetry in time at the quantum level that we don't perceive or experience at the level of our everyday reality, this opens up discussions about the inequities entrenched in our conventional perceptions of time that are often tied to linearity. It encourages us to question how time, as a social construct, has been used to enforce norms and hierarchies, and how a quantum-informed perspective could inspire more equitable frameworks for organizing our lives and understanding reality. Shortly after leaving Geneva, Black Quantum Futurism held a solo exhibition at Red Cat in Los Angeles called CPT Reversal, drawing directly on my research at the CERN laboratory, as well as our long-standing exploration of colored people's time. And like the residency, this series of works echoed the themes of time and temporality at various scales and dimensions. One of the central pieces in the exhibition was the CP timeline, a nonlinear timeline tracing the usage and history of colored people's time and CP theorem in books, magazines, and other media. And this timeline, displayed alongside the archive of media in which that term is referenced, is more than just a chronological sequence of events. It is a visual and conceptual representation of how these moments in time are not isolated or incidental, but are part of a larger interconnected narrative. And this narrative, again, spans the personal, it spans the communal, it spans the global, it spans the cosmic, and it highlights how time and temporality impact and are impacted by a multitude of factors. This perspective aligns with the notion that events, cultural shifts, and scientific discoveries are not just happenstance, but are part of a broader interconnected system. And in the middle of this timeline, we screened a 3-channel film, which will play here tomorrow, Write No History, which centers around the speculative narrative of temporal disruptors, members of an ancient secret society of Black scientists, healers, and writers transporting a quantum time capsule between the future, the past, and the present. And I'll talk about one more work, and then I'll wrap it up. But another central work in CPT Reversal was the Black Hole Viewfinder. This was designed to provide a glimpse into the mysterious depths of a black hole. Utilizing an array of lenses, the viewfinder aimed to mimic the distorted visual experiences of observing objects through a field altered by gravitational forces. This design premise underscores a critical argument. Our current scientific grasp of black holes is significantly hampered by the paradigms that we employ to interpret their phenomena. And in the book, I contend that these limitations are not just scientific or observational, but that they're actually entwined with the broader cultural and philosophical frameworks that shape our understanding of blackness. By synthesizing Black traditions and Afro-diasporic perspectives, our project called for the re-examination of the concept, urging us to move beyond those conventional associations with physical traits and color, and by extension, racial categorizations. And in this reimagined context, Blackness is not confined to terrestrial or corporeal boundaries, but extends into cosmic and metaphysical dimensions. Western scientific paradigms, which are often characterized by a reliance on the conventional properties of light and a purportedly objective lens, tend to bind our understanding. But in contrast, Black ontologies free us to explore the myriad possibilities of the multidimensional concept of Blackness and of time that permeates deep space, that permeates our mental space and our inner space, and brings space-time matter into deep entanglement. This expansive approach does not simply reconfigure our understanding of Blackness within the cosmos, it promotes a deep entanglement of space-time matter, all one word, fostering a holistic embrace of the universe and all it holds through a uniquely Afrofuturist lens. This ontological shift invites us to perceive and engage with the cosmos in profoundly transformative ways, challenging the very foundations of traditional scientific inquiry and opening up avenues for a more inclusive and exploratory cosmic narrative where black holes symbolize not only points of no return, but also sites of infinite potentiality. Thank you.
Thank you, Rasheedah. Rasheedah is presenting tomorrow in the Museum of Art and History at 7, if anyone is interested. And I wonder where people can buy the book.
You can buy it online, anywhere you buy books.
Okay. Yes. Not in Amazon. Okay. So my colleagues here are starting to transform this space for the performance of Maria Arnal. And while they are doing that, I'd like to introduce the artist. Maria Arnal is a Barcelona-based artist, singer, composer, and one of the Spain's, I would say Europe, the world, most innovative and prominent contemporary music voices, known for blending avant-garde pop, electronics, and traditional polyphonic music. She has performed at major festivals like Sonar and TED Talks in Vancouver. Her project include Earth from the 2021 Venice Architecture Biennale and Sirena for Hyper Mirador Torreglorias in 2022. In recent years, she has been exploring the possibilities of AI-powered digital instruments inspired by her voice, experimenting with synthetic voice models such as timbre transfer and text tossing as an artist in residency at the Barcelona Supercomputing Center. The work earned her an honorary mention at Ars Electronica 2024 Start Prize for Maria Carr, a sound installation exploring chorality and database sovereignty. These tools now shape her new repertoire, set to debut at Sonar, and she is coming to CERN to present these explorations and recent experimentations with these tools. So the performance today is called Uncertain Polyphonies, and Maria is using her research on synthetic voices and databases to present a performance that is unreleased. It's an unreleased choral composition featuring her various vocal models. Centered on the new vocal narratives enabled for AI tools, this concert unfolds at the intersection of synthetic polyphony, data set creation, digital luthery, and the expressive power of her physical voice. I don't know if Maria is ready, but let's wait for this exceptional moment. Thank you very much.
Thank you so much. I'm so happy. Thank you, Mónica, for inviting me to this amazing gathering. As she said, I've been developing kind of instruments around my physical voice through AI, through synthetic voice models. I have trained so many different ones on my own voice. So we always have our voice, but our voices are not always the same. They change with our bodies. We've had a child voice, we had a teenager voice, we've had a more mature voice. And then at the end of our days, we will have another kind of voice. I'm very interested in how specifically voice is modulated, and I've been training all these models, building kind of archivals of those bodies I'm living, or those selves I'm leaving behind. For example, nowadays, I'm a bit cold. My voice is super 80, Normally I can make it more brighter, but since I've been sick, in the past weeks, it's more 80. So, for example, last time I was sick, I was building a database with this kind of nuance, in a way of keeping those specific sounds of a moment that then I can use to compose in these choral polyphonies. I want to say that this is material that I'm kind of opening to you, sharing with you. You are the first people that are listening to these songs, apart from me and my closest friends and family. And I'm so excited to see how you react to them. They are built on improvisations and using all these tools to compose and creating patterns, creating landscapes of choral landscapes where my voice is not the leader in most of them. It's just a part of that choir. I'm going to continue with this one that I'm very happy to sing, and just hope you like it. Les pedres pel mig s'arromparan i les muntanyes s'afondran. Que el foc del cel davallarà mars, fonts i rius cremaran. El sol perdrà la claredat. Mostra'ns la fosquia alterat, la lluna no, d'oro claro i tot l'amor serà qui vol ser rei Thank you so much. This last song was the first one in which I could see my voice trained as a synthetic one. Thanks to the collaboration I had the honor of having with Holly Herdon, a pioneer and a true inspiration for me of this technology. And this song I just sang, it's not a new repertoire, okay, just to be super honest. But for me, it's very emotional because it's kind of like the starting point of this time of research and deep curiosity around this technology and what I can do creatively with it. It's a medieval song. It's a super old song that is sung by a traditional character, which is like the Sibyl, and she can foresee the end of the world. And she, in the song, she describes all the landscape in the middle of the destruction. Okay, we're going to continue. How are you? I want to invite you to sing very smoothly, just the people that want to, okay? We are speaking about chorality and uncertainty, and I think it's just amazing to listen to our voices together. We may don't have like the opportunity to listen us in the middle of a choir, and I just enjoy it very much. It's so basic as that. So I might say something, and then you can just repeat it how you feel it, okay? Ah, 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 ah. it there. Ah, 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 Thank you so much. Very beautiful. We go back to another experiment. Okay, this is another one where there is like a clear leading voice, okay, and it's an a cappella, it's mine, and then my choir on the side, on the back side of it, it's 3 different models trained on different databases. And it's a song, this one I made for a film, but I used these tools for composing it. Porque está brillando el sol, porque no cayó la luna, porque no se para el aire. Si tú ya no estás aquí, hay días que duran años, hay días que son eternos y corazones tan fuertes que ni la muerte se lleva.
Tus sueños son tan altos que van más allá del cielo. Tus sueños son tan altos que van más allá del cielo. ¿Quién cerró tus ojitos? ¿Quién cerró tus ojitos? No dejará de tenerlos. No llegará de tenerlo, no llegará de tenerlos.
I love this following song. We are kind of arriving to the end of this performance. And I want to finish with this song.
esmolats, com la mesa i l'espasa cap a cap va cremant tota la meva cuirassa, com ganivets esmolats, com la mesa i l'espasa cap a cap va cremant. El cel sol, estela de llum, espal metàl·lic que fulgura cada vegada més avall i no sé com demana ajuda. Ara tanto jo ens tan dura, perdo la meva armadura i l'abraço tan fort com si fos la teva cintura. Peça a peça, pètals vençuts, un per cada veritat absoluta, un per cada certesa total, cap que freni la clara caiguda. Cada capa de l'atmosfera em va deixant més i més nua i potser vaig més lleugera, però la pena és tan severa. Cada capa de l'atmosfera em va deixant més i més nua i potser vaig més lleugera, però la pena és tan severa que l'arrossego com una d'esperança. Vull un canvi de partitura, vull cantar una aliança, vull canviar la llei futura. Ara tanto jo ens tan dura, perdo la meva armadura i l'abraço tan fort com puc, com si fos la teva cintura.
Thank you so much.